Thank you, sir. So how do you take a year's worth of design calculations and accomplish that in a week? Once you achieve this, repeat again and again for every solar project downstream. The only possibility is through diligent automation, which takes all prior effort to every site, providing major benefit not only to us and the end client, but also the environment. Climate change, which affects us all, is going to take unprecedented effort and innovation. Energy transition is a key factor in reducing climate change, and the renewables industry is expanding and evolving rapidly. Energy generation on a renewables form has been predominantly from hydro, shown here in blue. Solar and wind are clearly leading the way for the energy transition, with solar set to increase 750% over this decade. That 750% is equivalent to 10 billion solar panels, which is enough to cover half of Nova Scotia. A big reason as to why wind and solar are leading the way is their cost. Solar alone has decreased 90% over the last 12 years. Now, in order to generate solar energy on an industrial scale, you use a solar farm. Now, site criteria for a solar farm, there are many different variables. Some of them being, is there a transmission line close by for tie-in? What are the property costs? Are there any certain permitting or land agreements that are required? And topography, which is the most important from a civil designer's perspective. And as you can see on the right-hand side of this image, this site is extremely flat. So that means there's no vertical variance to account for. And essentially, we can just give them the coordinates of the racking information. And from my end of things, it would be all done and complete. Now, topography falls fairly low on that list. So sometimes we end up with a site like this. This is Traverse, Canada's largest solar farm. And as you can see by the contour lines in yellow and cyan, it was comprised of rolling hills, which gave a lot of variability to the existing ground. Underneath that, you can see the racks or solar panels that are in blue and orange. And this is only representative of blocks 10 through 12 out of 153 on this site. Blocks 10 through 12, as you can see better in this, is the existing ground model. Now on this existing ground model, you can see that rolling terrain. But as well, if we're to use an industry standard method of laying out the racks for this site, what we're doing is we're taking the existing ground elevation at either end of the rack and running it as a straight line. What that does is it runs it through hills and over valleys. As you can see, this site would require an extensive amount of earthworks in order to lay out this site in a vertical sense. What I was able to do through SPOT, or the solar pile optimization tool, is to better follow the existing ground. And what it does is it not only follows the existing ground with the racks themselves and balances the cut and fill and so on, but it's also checking the vertical variance from one rack to the next and taking that association from every single pile that is on site. Now, this is flipping back to the industry standard just to give you a quick comparison. And this is SPOT again. Now, you can see very little variance with the actual elevation of the racking, but that little variance on each individual rack is going to cause a major transition for the entire project. The racking that we use for Traverse are called trackers. Now, what these trackers are is comprised of the solar panels, which are mounted to that central torque tube. That central torque tube is approximately 100 meters long. So that's a 100-meter long straight line that we have to run across the existing grade with very little tolerance to play with. This entire system is resting on these pile or posts, and they obtain their name as a tracker because they start facing 50 degrees east in the morning. They'll actually track the sun as it moves across the sky during the day and finish off 50 degrees west at the end in the evening, resetting overnight for the next morning to face the following sunrise. This is a similar tracker, or the same one, shown in a section view. Now, what this section view shows you is that industry standard, which runs that orange solid straight line from existing ground to existing ground on either end. By doing so, the upper dash line is reflective of the minimum pile height. The lower dash line is the maximum pile height. So anything above that upper dash line needs to be taken away or removed from the existing ground, and anything below that lower dash line needs to be filled in. As you can see, we're causing more cut than we are fill in this situation. And to optimize it, what we can do is simply raise the left side. Now, this is a very simplistic approach, but through SPOT, we're able to optimize not only for balance and cut and fill, but many other perspectives. So the upper portion that was in cut is now balanced or equalized with the amount of fill that's required in this situation. going back to the industry standard, that amount of cut would have to be either moved to a different location on site or hauled away entirely. Now, by manipulating the elevations of the racking, we're opening ourselves up to an enormous amount of variability. We're also balancing the cut and fill as we do this, but in order to reduce that variability, we're checking the vertical variances from every pile and its associated neighbors to ensure that they're limited to predefined numbers or values. So in turn, we're reducing the shading. We're also able to pull above any potential floodplain elevation or any potential floodplains that are in the area, keep to that minimum maximum pile height, but as well the max sloping of the tracker itself. Now these are a few of the parameters, just to give you a quick understanding, but as well at every pile, there are 12 variables that we need to account for, and there are an additional 4 variables that need to be accounted for at either end of the tracker. Back to Traverse, it was comprised of 1.3 million panels and 225,000 piles. Now, from a civil design perspective, if I'm to take 30 seconds and analyze every pile, that would take a year's worth of design time to go through. The project area was 3,338 acres, which is equivalent to 1,900 soccer fields, or 4 times the size of Central Park. And there were 17,000 trackers on site that we need to account for. Shown in that small white box is blocks 10 through 12 out of 153. And as you can see in the aerial image, those rolling hills were stretched out across the entire site. Now, through SPOT, this is what we had as a proposed grading scenario. What's shown in red are the hills that we need to cut off, and in green, the valleys that we need to fill in. Everything else that is uncolored is simply left untouched or undisturbed. Now, a big reason for generating SPOT on this project is that we needed to link the pile and grading information, so that if there was any change to a single pile on site, it was reflective and dynamically updated within the grading itself, and as well back-checked against every surrounding pile. The client timeline was extremely fixed, and to be honest, we hardly had enough time to even do it as a standard method. We're able to take the hours of data manipulation and turn that into a click of a button, which takes a few minutes to analyze the entire site, automating the calculations from not only the initial input, but all the way through to the final design. So the unique value proposition that we're able to offer future clients is we're able to streamline the design process, reduce the earthwork, reduce construction time, and as well reduce land disturbance. So overall, we've taken the design calculations from months to days to hours. We've significantly reduced the client or contractor and the owner's time and expense. We dynamically linked all the data and validated it across the entire site. And at the end of the day, when this solar farm has reached its ultimate design life of 35, 40 years and all the equipment is removed from site, we're left with a far less disturbed and natural environment. Thank you.